Hello and welcome. In this video we will learn how to solve inequalities using the properties of real numbers for inequalities. For any real number, a and b, exactly one of the following is true. Either a is less than b or a is equal to b, or a is greater than b. This property is called trichotomy. Trichotomy property of real numbers. Now we'll see the addition and subtraction properties of real numbers involving inequalities. For any real number, any real numbers a, b and c, if a is greater than b, then a plus c is greater than b plus c, which means a real number can be added to both sides of the inequality and produce an equivalent inequality. Same way, a minus c is greater than b minus c, and if a is less than b, then a plus c is less than b plus c, and a minus c is less than b minus c. We'll be using these properties in solving the inequalities that we will be doing in the subsequent pages. Now let us solve this inequality using the properties we just discussed. 3x minus 7 is greater than 2. Is the given equation, given inequality, I'm sorry. Adding positive 7 to both sides. Dividing both sides of the inequality with 3 gives you x is greater than 3. We can represent this on a number line for example, if this is a number line with 0, now x greater than 3 involves all the points that are greater than 3 but the number 3, all the numbers except the number 3. So you can try to see if this inequality is true for numbers which are less than 3 and substitute them here in this given inequality and find out. If you take 2, that would be 6 minus 7, which is -1, is not greater than 2. So any number that is less than or equal to 3 would not satisfy this inequality. Let us take another example. Solve for x plus 5 greater than or equal to 25. Here we have greater than or equal to. This is the given inequality. Now let us add -5 to both sides. That gives you 4x plus 5. Adding -5. Now dividing with 4 on both sides. So x is greater than or equal to 5. If we represent this on a number line, you will have the values of x, all the values of x including 5 and greater than 5 satisfying this inequality. 4x plus 5 greater than or equal to 25. Let us draw that graph now and see what it looks like. In this graph, all the values of x which are greater than or equal to 5 would satisfy the inequality. So the values of x include the set of all the values which are greater than or equal to 5. This can be written in set builder notation as set builder notation as all values of x such that x is greater than or equal to 5, which means all values, all real values of x such that this line indicates it's such that x greater than or equal to 5. This is called writing in set builder notation. Let us take another example. Solve 7x plus 4 greater than 6x minus 2 So we have variables on both sides of this inequality, so it would be lengthier than the ones that we did previously. But let us follow the properties of using the properties of real numbers for inequalities, and let's solve for x. Adding -4 on both sides. So given inequality, so that gives here plus 4 is greater than 6x minus 2. That's the original inequality. You're adding -4. You are either adding -4 or subtracting 4 from both sides. It's the same. Seven x is greater than 6x minus 6. Okay. Adding -6x on both sides. Adding -6x is same as subtracting 6x on both sides, from both sides. Okay. 7x -6x greater than 6x minus 6 minus 6x. So that gives you x greater than -6. So x will have all the values which are greater than -6, but not -6, because it's greater than. It must be strictly greater than -6. It's not greater than or equal to, like in previous example. Let us plot this on a number line. And on this side you have negative numbers, -1, etc. Now x greater than -6, which is, it must be greater than all the numbers which are greater than -6, all these numbers. All the numbers which are greater than -6 but -6. It doesn't include -6. So the graph looks like something like this. Now to write this in a set builder notation, set builder, all values of x such that x is greater than -6. This line is read as such that that is for all x or set of all x Thanks for watching.